So now we start with the topic on LCM, least common multiple. Let us first find out what is actually an LCM, and then we'll see as to what are the methods to find the LCM for 3 to 4 numbers. So what is an LCM? What is the least common multiple here? First we'll talk about multiples. So let's take 3 numbers, 5 and then 10 and then 15. My simple question here is, what are the multiples of 5? So you will say it is 5, 10, 15, 20, 25, 30 and then so on. It will keep on going like this. What are the multiples of 10 now? 10, 20, 30, 40 and then so on. What are the multiples of 15 now? 15, 30, 45, 60 and then so on. After the multiple, I am asking you, next question is, what is the common multiple in this 3 number? Which is that one multiple which is common in all 3. So I'll start from 15, that is 30 is here, 30 is here and 30 is here. So my common multiple is 30. Then I am asking you a question, which is the least common multiple? So it has to be a common multiple, but the least one, which is again nothing but 30. So 30 is my LCM, least common multiple for these 3 numbers, 5, 10 and 15. Okay, which is the another multiple which will be common in them? 30, after 30 it will be 60, then it will be 90 and then so on, going like that. But the least among them is 30 and that's why it is my LCM. Okay, so that is the basic concept that you're supposed to know about LCM. Now let us find out what are the ways in which I can find the LCM for 3 numbers. So I give you 3 numbers here, 36, 42 and 56, and my question is, what is the LCM of these 3 numbers? So there are 2 methods to it. First method is called as a traditional method and the second is called as prime factorization. Let's look at each one of them. Let's start first with the traditional method. How will I write this now? 36, 42 and 56. What will I do here is, I'll solve it like I did it in schools. Start with any of the number. 2 18s are 36, 2 21s are 42, 2 into 28 is 56. Okay, what else can I do? Again I can go by 2 9s are 18, 2 14s are 28, 21 remains here. Looks like it can go by 3 3s are 9, 3 7s are 21 and 14 remains here. There is a 7 and then there is a 14 there. So I'll say 7 1s are 7, 7 2s are 40, 3 remains here. Then 3 1s are 3, 1 comes here, 2 is here, and then the last 2 1s are 2 and 1 1 1 comes here. As soon as the 1 1 1 comes here, stop, because 1 1s are 1, and that's what I find out my LCM by traditional method. Now what is the next step that I am supposed to do once I find out the LCM by traditional method? I will have to just multiply them. Okay, just multiply this. 2 into 2 it is 4, 4 into 3 it is 12, 12 into 7 it is 84. Okay, so that's what I understand, 84. Then 3 into 2 6, 6 into 1 6. Now just multiply this, 84 into 6, 84 into 6. What is the answer coming out to be? 6 into 4 is 24, 8 6 are 48, 50, 504, and that is my answer. So the least common multiple for 36, 42 and 56 is nothing but 504. That's how I find it out. So that's how my traditional method says. What about prime factorization? What do I do in this? Now I write 3 numbers, 36, 42 and 56. And what do? I write them in terms of prime numbers, prime factors. So I will write 36 as 2 into 18. But the problem here is 18 is not a prime number. So I'll have to split up 18 such that it comes out to be as a prime number. 9 into 2 is 18. So if I write this as 9 into 2, what am I getting out of this? 2 is a prime number but not 9. So I'll have to convert 9 to a prime number, 3 square. So I can write this as 2 square into 3 square. Or 9 4s are 36, where 2 and 3 both are my prime number. How do you do the same for 42? 6 7s are 42. I'll write 6 as 2 into 3 into 7. That's it. All 3 are prime numbers now. Then I'll come to 56. 7 8s are 56. But 8 is not a prime number, so 7 into 2 cube is what I'll write it in. Okay, now I got all the three in terms of prime number. Now what am I supposed to do? How many distinct number can you see it here? Distinct means unique number. So 2 is one distinct number, 3 is one distinct number, and 7 is one distinct number that I can see it here. Okay, that's what I first get it from this. 2, 3 and 7 are the only three numbers that I can see in this. So write all three. Now whenever they ask for least common multiple, for least you need the highest power. Okay, so remember it in this way. For the least you need the highest power. Okay, so can you tell me what is the highest power of 2 in all three? What is the highest power of 2 in all three? The highest power of 2 is 3. Okay, it is 1 here and it is 2 here, so the highest power is 3, so I'll take here 3. Now what is the highest power of 3? After 2, what is the highest power of 3? Here it is 3 raised to 0, so ignore this. 3 raised to 1 and 3 raised to 2, so the highest power is 2. And now see the highest power of 7. Here it is 7 raised to 0. Here it is again 7 raised to 1. Okay, and here also it is 7 raised to 1. So what is the highest power? Take any one of them, 7 raised to 1. So I will write this as 7 raised to 1. Now just multiply. What is this coming out to be? 2 into 2 into 2 is nothing but 8. 8 into 9 into 7. 8 into 9, 72. 72 into 7 is my final answer. 72 into 7. What is that turning out to be? 7 into 2 is 14. 7 7s are 49. 504. And that's my final answer. As I got it with the traditional method as well. If you can see, there is a pattern here. We are talking about 3 2s here. I already got 3 2s here when I solved it by traditional method. I am talking about 2 3s here. I got 2 3s when I solved it by traditional method, and I am talking about 1 7 here. The 1 7 was already here. So it's the same answer that I am getting it here, but the way in which I solve is different. Ideally, we'll prefer prime factorization because the next topic that we'll study, HCF, can also be found out by prime factorization. So if a question asks you for both LCM and HCF, then prime factorization turns out to be the simplest of method. Now one more thing you have to remember here is, how do I visualize? How do I visualize this? See, you need something that is a multiple of 36, multiple of 42 and multiple of 56. So you need some basic terms which will be there. Okay, so I need the basics 2, 3 and then 7. And then I take the highest power of them. Why do I take the highest power? Because I am looking for a multiple. Okay, because I am looking for a multiple of them. So what am I doing it here is, I already take, if I take 2 raised to 3, the highest power of 2, I had already considered 2 raised to 2 here now. If I take 3 raised to 2, I had considered this as well now. If you are taking 2 raised to 3, you had considered 2 raised to 1 and 3 raised to 1. If you are taking 7 raised to 1, you had considered this as well. If you are taking 7 raised to 1, you had considered this. If you are taking 2 raised to 3, you had considered this, which means the number that I will be getting has to be something that is common to all three, because it is considering this, this and this. So it is common to all three and it is least. Why? Because I am not increasing any power. I am not putting 7 power 2. I am putting, what is the maximum power of 7 here? 1. So I will get the least of the common multiple, and that's why this is the method to get an LCM. Okay, so remember this. We'll use this in the next class. So after LCM, now let's come on to the concept of HCF, that is highest common factor. So let us first understand what is an highest common factor. So let's take our three numbers, 5, 10 and 15. We know the multiples of them, but what is actually the factors of 5? Factors means a number which divides 5 giving a remainder of 0. So 1 5s are 5 and 5 1s are 5. These are the only two numbers which divides 5. So they are the factors of 5. Now what are the numbers which divide 10? 1, 1 10s are, 2 5s are 10, 5 2s are 10, 10 1s are 10. Right, so there are 4 numbers which divide 10. Similarly, what are the factors of 15? The number which divides 15. It will be 1, not 2, 3, then 5, then 15. That's it. Okay, that's what I can see it here. Now what is it like being asked to me? Factors, I know that. Common factors. So what are the common factors? 1 is obviously a common factor in all of them, of course. Okay, what is the next common factor? 5, I can see it there. 5 is there in all 3. So I can see 2 common factors here. But what is the question asking me? Highest common factor. So which of this is the highest? Obviously it is 5 here. Okay, that is highest in all 3. So 5 is my HCF here, highest common factor. So if you can see it here, what is it like we are doing? LCM, we get the least common multiple, okay, and in this case we get the highest common factor. We cannot get the least common factor. What will happen if you get the least common factor? It will always be 1, because 1 is a factor of every number. So why do you need to get the least of the common factor? This will not help me to solve real life problems, which we'll see in the next part, the word based problem coming in LCM and HCF. So we need to get the highest of the common factor, because this will help us to solve a lot of problems. Okay, so remember HCF and LCM. Now once we know the concept, let us come on to the method to find out HCF. So I am giving you 3 numbers right now, 288, 432 and 768. Let's write them, and I need to find out what is actually the HCF, highest common factor of these numbers. So let's start. How will I do that? I'll do that by prime factorization. We had seen the prime factorization method while we solved LCM, and I told you use this method regularly because this will help you to find out both LCM as well as HCF. Okay, let's see how does it help me to find out HCF. So first write 288 in terms of prime numbers. How will I write this? I can write this as 144 into 2. Right now 144 is nothing but 12 square. So I'll write this as 12 square into 2. Still not getting prime numbers. I'll write this 12 as what now? 4 into 3. Okay, and this 4 is nothing but 2 square. So this turns out to be what? 2 square raised to 2, which means this becomes 2 raised to 4 into 3 raised to 2 into 2. That's what I get it from here. So finally, if I were to just summarize this, this is 2 raised to 5 into 3 raised to 2. Right, that's what I get it from 288. Now let's come to this, which is 432. How can I write this as? I'll write this as 216 into 2. That is equals to 432. Why did I write a 216 here? Because this is nothing but 6 cube. So 6 cube into 2 is what I'll write it here. But what is 6? 6 is nothing but 2 into 3 raised to 3 into 2. So what is it like I finally get from this? This is 2 to the power 3 plus 1, 2 to the power 4 into 3 to the power 3, and that's what I get it finally from here. Now let's come to the last number, that is 768, and see what is it like I can split it up into prime numbers. So if you don't get a click to this, solve it here by the side by the means of prime factorization. So I'll write it here as 2 3s are 6, then it is 1 6, 2 8s are 16 and 2 4s are 8, then again 2 1s are 2, 2 9s are 18, 2 2s are 4, 2 9s are 18, 2 6s are 12. As soon as I see a 96, it clicks me. 12 8s are 96. Let's just do it by 2 only. We'll get the power of 2 only then. 248, 224, 212, 26 and 2 3, and then 3 1. That's what I get it finally. So how many 2s are here? 1 2 3 4 5 6 7 8. 2 raised to 8 into 3. So I can write this as 2 raised to 8 into 3. That's what I did it here. Okay, once done with this, what are you supposed to do? Just as you do it in LCM, you need to see the distinct terms here. Distinct terms. So what are the different numbers that I can see in this? Let's compare all the 3. This is the one, this is another one, and this is the last one. Let's compare all the 3. So what are the different numbers? I can see only 2 numbers here, 2 and then 3. So I write the 2 numbers, 2 and then 3. Then what will you see? In LCM you saw the highest power, right? In LCM we saw the highest power. In HCF, if this is highest common factor, you see the lowest power. Okay, so in LCM this was least you see the highest. In HCF this is highest, so you see the lowest power. And it's quite a logic, because I need a factor here. If I need a factor here, I need to see the lowest power. In a multiple, I will see an highest power. So see the lowest power of 2 here, which is the lowest power of 2. This is highest, 8, 4. 4 is the lowest. 4 is the lowest. I can see 4 is the lowest because 5 is again the highest. So I'll write 2 raised to 4, the lowest power. Then I'll see 3. What is the lowest power of 3? Here it is 2, here it is 3, and here it is 1. Correct? So I'll write it as 1. That is the lowest power of 3. This is my answer now. 2 raised to 4 is 16. 16 into 3 is 48, and 48 is the HCF, highest common factor of this 3 number, and the problem is solved. Okay, so use prime factorization and it will be easier for you to get both LCM and HCF. Now, in case you want to visualize the logic, how did this happen? You need a factor of this number, right? So what did I do? I got the basic things which is required for this number, which is 2 and then 3. So I got 2 and then 3. Then I got what is the minimum power of 2 and then 3 that I require, so that it can divide this number and this number. That's why you always take a minimum power here. So 2 raised to 4 into 3. So remember this basic logic and you will always get the answer for HCF. Now let us see a concept where we find out LCM and HCF but of fractions. Yes, so how do you solve that now? We had seen for normal numbers how do you get it, for integers how do you get it, but let's now do it for fractions. So I give you 3 numbers, 1.8, 2 and then 2.4. These are the 3 numbers that you get, 1.8, 2 and then 2.4. I need to find the LCM and HCF both for these 3 numbers. What will I do? First I'll convert them to fractions. So I'll write this as 18 by 10. Then I'll write this as 2 by 1, and then I'll write this as 24 upon 10. I will make sure that they have a numerator as well as a denominator. So fraction, I convert it to this part. Now what will I do? I need to find out what is the LCM of this, and then I need to find out what is the HCF of this, right? So first I need to find out LCM of this. So remember a trick. Whenever I ask you to find out LCM of this 3 numbers, which is nothing but LCM of this, so for LCM you always take the LCM of numerator, which is my numerator 18, 2 and then 24. That is my numerator. And you will take what? HCF of the denominator. HCF of the denominator. What is my denominator? 10, 1 and then 10. So if I ask you LCM of numerator and HCF of denominator. That's the trick here. Okay, now let us find it out. What is LCM of 18, 2 and 24? So when you get 3 numbers which are small numbers like 18, 2 and 24, and I ask you the LCM of this, start from the highest number, which is 24. See the multiples of 24 and see if they are multiples of 2 and 18 as well. So 24 ones are 24, not the multiple of 18. 24 twos are 48, not the multiple of 18. 24 threes are 72, multiple of 18 as well as multiple of 2. So 72 is the LCM of these 3 numbers. Now I need to get the HCF, highest common factor of 1, 10 and again a 10. What is the highest common factor? There is one factor which is 1. Okay, 1 has only one factor, that is 1. So obviously the highest will be 1 only here, because there is only one factor to 1, that is 1 itself. Okay, even if I have a 10 or I have a 2 or I have a 5, it doesn't matter, because there is only one factor here, that is 1 with 1. So it has to come out to be 1. 72 divided by 1, the answer is what? 72. And that is the LCM, least common multiple of 1.8, 2 and then 2.4. Okay, that's what you will have to imagine, and they get the answer as 72. And it's quite a logic as well, right? Because 2 into 36 will give you 72, 2.4 into something will give you 72, and 1.8 again into something will give you your 72. Okay, which is nothing but if I multiply this by 4, this becomes 7.2. If I multiply this by 40, this becomes 7.2. Okay, if I multiply this by 3, it becomes 7.2. But if I multiply this by 30, it becomes 72. Right, which means it's an LCM of this 3 numbers is 72. Make sure you visualize this in the end as to actually will it be an LCM of these 3 numbers. Now let's go on to the next understanding as to finding out the HCF, highest common factor for these 3 numbers. So what am I asking you now? HCF. HCF of what? The same, 18 by 10, 2 by 1 and 24 by 10. I need to find out the HCF of this. So in LCM, what do? Take the LCM of numerator and HCF of the denominator. In HCF, what will you do? Take the HCF of numerator and LCM of the denominator. Just the reverse. LCM, you have numerator LCM, denominator HCF. HCF, you have numerator HCF. Whatever is here comes in the numerator. As simple as that. So HCF of numerator 18, 2 and then 24. And then the LCM of denominator. What is my denominator? 10, 1 and then 1. And my problem is solved. So how will I solve this now? Highest common factor of 2, 18 and 24. What is that? 2, 18 and 24. 2 has only 2 factors, 1 and then 2. 2 will be a factor of 18, 2 will be a factor of 24 as well. And since there are only 2 factors to 2, highest has to be 2 here. Right? Because there are only 2 factors to 2. As it happened here, there was only 1 factor to 1. So it has to be the highest because that's the only factor. In this case, 2 has to be the highest. So 2 comes to be my answer here as a numerator. LCM of 10, 1 and then 10. So if I write here 10, 1 and then 10, I need to find out the multiple of this 3. So 10 1s are 10, 10 1s are 10 and 1 10s are 10. 10 will be my what? Least common multiple. Okay, because the first multiple of 10 is 10. And if you have to find out, every number is a multiple of 1. The first multiple of 10 is 10. So that has to be my least because that's the first multiple. Okay, so it is nothing but 10. I'll write it here as 10. If I cut this now, 2 1s are, 2 5s are 10. 1 by 5 is nothing but 0.2. 0.2 is my answer here. Which means that the highest common factor, HCF, highest common factor of this 3 number is 0.2. 0.2 divides 1.8. Yes, it does divide 1.8. Does it divide 2? Yes, it divides 2. Does it divide 2.4? Yes, it divides 2.4. And that's why it is the highest common factor of the 3. Okay, so understand this basic. What are you supposed to remember here is, in case you get a fraction here, what are you supposed to do? LCM of fraction, if I ask you, then you have to do LCM of numerator upon HCF of denominator. And if I ask you HCF, then HCF of numerator upon LCM of denominator. This is a simple trick that you have to remember to get LCM and HCF of fraction. Now let us study a few properties of LCM and HCF. We'll use this property to solve many problems. We'll see the problems in the next section. But let us first understand what are these properties of LCM and HCF. So product of two numbers is equals to LCM of numbers into HCF of numbers. So product of two numbers is LCM into HCF. Let's verify this. Will this happen for any two numbers? It will happen for any two numbers. Let's take two numbers, 5 and then 10. What is the product of these two numbers? 5 into 10. 5 into 10, it will be what? This will be here, product of two numbers, 5 into 10. Their product comes out to be as 50. Is it equal to LCM of numbers into HCF of numbers? Let's check it. What is their LCM? Least common multiple. 5 and then 10 are the multiples of 5 and 10 is a multiple of 10. Least common multiple here is 10 only. So the LCM of two numbers is 10. What is the HCF of two numbers? Highest common factor for this. So 1 and then 5 are the factors of 5. Then 1, 2, 5 and then 10 are the factors of 10. So which is the highest common factor? That is 5. Okay, that is 5. That is a common factor, and that is the highest. So the HCF of two numbers is 5. Got it. So 10 into 5 is nothing but 50. So I got it correct. This will be true for any two numbers. Their product will always be equal to LCM of number into HCF of number. So do remember this property. We'll apply this in multiple problems. Now let us look at one more property of such type. HCF of two numbers is x. If HCF of two numbers is x, then I can write one of the number as x into a, the other number as x into b, where a and b are always co-prime to each other, and the LCM of two numbers will be x into a into b. Looks very confusing, right? Let's put it in numbers. If you put it in numbers, it will be easy. HCF of two numbers is x, so let's take our two number again to be 5 and 10. What is their HCF? Highest common factor of 5 and 10? We just found out it is 5. So let's write it here. In case of x, I put this as 5. Since the HCF of two numbers is x, so in this case my x is 5. So wherever I see an x, I'll write a 5 there. I'll write a 5 here, I'll write a 5 here as well, because now I'm giving it a value. We can write two number as x into a and x into b. So what will I write my a as here now? I have to write one number. What is my one number? One number is 5 and the other number is 10. So how can I write this? I'll write one number as 5 into 1. A has to be 1, then only I'll get a 5 here, which is one of my number. And here b has to be 2. Only when b is 2, I'll get 5 into 2, the other number to be 10. Correct. Okay, so I took two numbers, 5 and then 10. HCF was 5. I wrote one number as 5 into 1, okay, which is 5, and now here my a is equal to 1. I wrote other number as 5 into 2, which is nothing but 10. That is my other number 10. And quite a logic. If I have an HCF, I have to multiply it by some number to get that actual number, right? To get that actual number, and that's what I do it here. But what does the property says? A and b are co-prime to each other. Okay, so I have my a, which is 1, and I have my b, which is 2. Are they co-prime? Of course they are co-prime. Okay, first of all, what is actually a co-prime? What do you understand when you say co-prime? Co-prime are the two numbers which have highest common factor as 1. Those two numbers will be co-prime. For example, say 2 and then 19. What are the factors of 2? 1 and then 2. What are the factors of 19? 1 and then 19. What is the highest common factor? 1. So other than 1, they don't have any of the common factor, and that is their highest common factor. So they are called as co-prime. For example, two prime numbers will always be co-prime, 17 and 23. Because they have 1 and then 17 is a factor, 1 and then 23 is a factor. So the highest factor and the only factor here is 1, and that's how it will be. HCF is 1. Okay, that's what you have to understand, that HCF, highest common factor, is 1. Which two numbers are not co-prime? Let's take an example, 3 and then say 27. What are the factors of 3? 1 and then 3. What are the factors of 27? 1, 3, 9 and then 27. What is the highest common factor here? 3. Okay, not 1. So they are not co-prime. Co-prime needs to have the HCF of 1. Are they co-prime now? 1 and then 2? Of course they are co-prime, because 1 has only one factor, that is 1. So the common and the highest has to be 1. 2 has two factors, 1 and then 2. So the highest common factor here is 1. So they are co-prime. Okay, after understanding this, what do I need to know? How do I get the LCM of this? LCM is written as x into a into b. So you know what is x? X is 5. You know what is a? A is equals to 1. You know what is b? B is equals to 2 according to this problem. So 5 into 1 into 2, which is nothing but coming out to be as 10. Correct, I know. The LCM of these two numbers, 5 and then 10, is nothing but 10. So I got it all correct. This will be true for any two numbers. Now I took 5 and 10. You try it with 10 and 20. Okay, please pause the video and try it. So I hope you must have tried this now. Let me do this for you now. Now highest common factor for HCF of this two number is what? 10 and then 20. What is the highest common factor here? Factor of 10. 1, 2, 5, 10. factor of 20, 1, 2, 5, 10 and then 20. Highest common factor here is what? 10. Right, that is the highest common factor. So the HCF of two numbers here is equal to 10. One number could be written as x into a. So I can write one number as 10 into 1, 10. And I can write the other number as 10 into 2, 20. Right, what is my a and then b here? Again 1 and then 2. Okay, this is 1 and this is 2. So a and then b are again 1 and then 2. I can write the LCM as x into a into b. So what is my x here is 10. Okay, my a is 1, my b is 2. 10 into 1 into 2, 20. And that is nothing but the LCM, least common multiple of 10 and then 20 is nothing but 20. I got it. Take any two random numbers, you will always see that these properties hold true with respect to LCM and HCF. Okay, so please make sure you practice this enough, because in the next section we will see the application of these properties. Now let's apply what we have learned. We have learned the properties of LCM and HCF. Now let's apply that to problem. What is being given to me in this problem now? HCF of two numbers is 7. LCM of two numbers is 196. Difference between the two numbers is 21. What are the two numbers? So I'll just blindly apply the properties that I know. If I know that the HCF of two number is 7, I can write one number as 7 into a, and I can write the other number as 7 into b. How do I do that? If you can remember the previous property, HCF of two number is x. We can write two number as one number to be as x into a and the other number to be as x into b. So my x now here is 7. So I can write 7 into a and 7 into b as my two numbers. That's what I did it here. So I already know what are the two numbers. One number is 7a and the other number is 7b. All I need to do is get the value of a and b, and I'll come to know what are the two numbers. I need to find out what is a and b. What next? LCM of two numbers is 196. What is the meaning of this? 7 into a into b is equals to 196. Now how do I know that? I studied this in the property. If the HCF of two number is x, two numbers are this, 7a, 7b, x here is 7, where a and b are co-prime, okay, but the LCM here is equals to x into a into b. We know this as well. My x here is now 7, so 7 into a into b, that will be the LCM, and that is nothing but given to me as 196. So I write this to be equal to as 196. What do I get from this? I get a and b. Okay, what can you get? 7 2s are 14, then 5 6 is remaining. So what do you write it here? 28. So a into b is equals to 28. So I understand the product of a and b is 28. But I also know that a and b are co-prime to each other. That is something that is being known to me. Okay, how do I know this? Because I studied this in the property here. The property says that a and b are always co-prime to each other. So that's what I know as soon as I solve this problem. Now I try and get the product of a and b. A into b is 28. So what can it be? A could be 1, b could be 28, possible. 1 into 28 is 28. 2 into 14 is also 28, correct? What else can I get? 3, no, 4 7s are 28, correct? I can get this as well now. Okay, what else? 2, 3, 4, nothing else, right? Nothing from this. Now, what will you see here? See, 1 into 28 is similar to 28 into 1. So don't take that to be a different case. 2 into 14 is same as 14 into 2. And 4 into 7 is same as 7 into 4. Why do I say this? Because my two numbers are 7a and 7b. I already know that. So if a is equal to 1 and b is equals to 28, I'll get the same answer. If a is equals to 28 and b is equals to 1, I'll still get the same thing here. So it doesn't matter if you take this to be as 7 and this to be as 4, or you take this to be as 4 and this to be as 7, it doesn't matter, because eventually you are multiplying both by 7, right? So it doesn't matter. So this all are same case. So what do I get? This could be the value 1, 28, 2, 14, 4, 7. These are the value that I get. Now let's try and get this. If I say A is 1, one number will be 7 into 1, it will be 7. If I say B as 28 into 7 is what? 140 plus 56, 196. I get the other number. So if I say this to be the case, I get two number as 7 and 196. Is this my answer? No, because the problem is saying the difference between the two number is 21, and if you see the difference here, it is not equal to 21. So these are not my numbers. So this is not my case. Second, I see this. As soon as I see this, I reject this. Why? I'm not even making a number out of this. I'll straight away reject this. Why? Because these two numbers, 2 and then 14, are not co-prime to each other. This is the trick which will help you to eliminate a lot of the combinations here. What is my condition? A and B has to be co-prime, right? Which means their highest common factor has to be equal to 1. If you can see, I have a 2 and a 14 here. The factor for 2 are 1 and then 2. The factor for 14, 1, 2, 7 and then 14. The highest common factor here is 2, which means they are not co-prime, and A and B has to be co-prime to each other. We know that. That's the condition. So this can never happen. Now let me try this case. When A is equals to 4 and B is equals to 7. If I take this to be as case 7 into 4, I'll get one number as 28. And 7 into 7, I'll get the other number as 49. Difference between the two, 49 minus 28, which is equal to 21. So I know the answer now. The two numbers are 28 and 49. Okay, their HCF, highest common factor, is 7. Their LCM, least common multiple, is 196. And their difference is 21. Okay, so just apply whatever you know from the property, and eventually you will reach always to your right answer. Know that what is given and how are you supposed to find out. HCF was given. I wrote two number. I know A and B has to be co-prime. I wrote the LCM. I got A and B. I got the combination. I eliminated few combinations by thinking that A and B has to be co-prime. So some of them are gone. Then I realize what is remaining. Okay, from that remaining, am I getting my condition satisfied? Yes. So that is my answer. Now let us look at one more sum, which is an application of properties of LCM and HCF. Now what has been given to me here? HCF of two numbers is 6. Product of two numbers is 4320. How many such pairs of numbers exist? So given this condition, how many numbers can I make? He's not asking us the two numbers as it was asked in the previous case. He's just asking me, if I give you this condition, how many numbers can you make? Okay, so let's start using what we learned from our property. If the HCF of two numbers is 6, I can write one number as 6 into A, and the other number I can write it as 6 into B. Okay, how do I know this? Again, my property. If the HCF of two numbers is x, one number is x into A, the other number is x into B. Now my x is 6. 6 into A, 6 into B will be my two numbers. So that's what I write it here. Product of two numbers is given to me as 4320. What is the meaning of this? Product of two numbers means now 6A, this is my one number, and 6B is my another number. So this is 6B. Their product is given to me as now 4320. That is what has been given to me as 4320. So what do I get from this? I get 36 into AB. Okay, that whole thing is equals to 4320. So I get now AB. AB is equals to what? That is equals to 4320 divided by 36. Okay, let's just cut this to get the answer. 36 ones are 36, 7, 72, 36 twos are 72, 120. So I get now my AB is equals to 120. Now what is the meaning of this? The product of the two, the product of A into B is equals to 120. That's what I know from this. What does my property say for A and B? What does my property say for A and B? A and B are always what? A and B are always co-prime to each other, right? This is what I something already know. What is co-prime? Their highest common factor is 1, and this is what I'll use it here now. So A and B has to be co-prime. Let us first see what can be your A and B. So this could be 1 into 120 is 120, 2 into 60 could be 120, 3 into 40 could be 120, 4 into 30 could be 120, 5 into 5 and 5 2s are 10, 5 into 24 could be 120, 6 into 20 could be 120, 7 cannot come, 8 will come, 8 into what? 8 ones are 8, 15 will be 120. Then what? Not 9, 10 will come, 10 into 12 will be 120. Okay, and what? And 11, 12, and again it will be 12 into 10. Okay, and as I told you, 1 into 120 is same as 120 into 1. Why? Because then one you are writing as A and one you are writing as B. So if you write 1 and 120 or 120 and 1, you will obviously get the same number because you are multiplying both by 6. Okay, so that is not what we consider here. 1 into 120 is same as 120 into 1. Now after writing this, what do I think here? How will I get to my answer? I need to know that this two numbers has to be co-prime to each other. This two. So which are not the co-prime? I am getting so many combinations, but this 2 has to be co-prime. So which are not co-prime? This is a co-prime, 1 and then 120, 2 and 60, they are not co-prime to each other. Their highest common factor is not 1, it is 2. Then they are co-prime, 3 and 40, they are not co-prime. Their highest common factor is again 2, so gone. 5 and 24 are co-prime, 6 and 20 are not co-prime. Their highest common factor is again 2, not 1, so gone. 8 and 15 are co-prime, 10 and 12 are again not co-prime. Their highest common factor is not 1. So which are the valid combination that I get where A and B are co-prime, which means their HCF is 1, their HCF is 1, highest common factor, 1 has only one factor. Their HCF is 1 because 3 has only two factors, 1 and then 3, and then the HCF will be 1 here. Their HCF is 1 because 5 has only two factors, 1 and then 5, and their HCF will also be equal to 1. So what do I understand from this? I can get 4 numbers now. That is what he is asking me. How many such pairs of number exist? I can get 4 numbers. Now 6 into A and 6 into B. That these are my numbers. Once I will substitute A as 121 and B as 120. One number. Then A as 3 and B as 40. Another number. So first pair, second pair. Then I will substitute A as 5 and B as 24. Another pair. Then I will substitute A as 8 and B as 15. Another pair of numbers. So 4 such pair. How many such pairs of numbers exist? 4. Actually I got it 8, but then I used the concept of co-prime to know what are my answer. Okay, so this is how you can use the learning that we got from the properties to solve various problems on LCM and HCF. Now let's see a comparatively difficult sum, which is an application of property of LCM and HCF. Now instead of 2 numbers, I give you 3 numbers. The product of 3 numbers is 1620. HCF of any 2 of the 3 number is 3. What is their LCM? Okay, so what do I understand from this? If the HCF of any 2 of the 3 number is 3, then I can write 3 number as 1 number as 3 into A. Other number will be 3 into B. But now I will have a C here as well, and the next number I will write as 3 into C. So now instead of A and B, what we get here in property, if the HCF of 2 number is X, X into A and X into B. I am saying if there are 3 numbers, I will write if their HCF is X, X into A, X into B and X into C. So my X here is equal to 3 now. 3 into A, 3 into B and 3 into C. A, B, C will all be co-prime to each other. Okay, and their LCM will be what then? 3 into A into B into C, because I am introducing a new variable C here. That's what will happen here. So I know this. What is their LCM is being asked to me. So I know what will be their LCM. 3 into A into B into C. That's what my property says to me. So I write it here. I need to find out this now. Now what is given to me? The product of the three numbers is 1620. So what do I understand from this? 3a into 3b into 3c. Right? So this is my 3b and then is my 3c. The product of this 3 is equals to what? 1620. That is being given to me. So I understand from this what? 3 into 3 into 3, 27. I get here 27 ABC. Okay, now think about it. You get 27 ABC is equals to 1620 here. So let's write it here. 27 ABC, which is A, B, C, and that is equals to 1620. I will keep this as now. Let's just take out 9 from this. So what will be remaining here is 3 into ABC. 3 into ABC. Why am I doing this? Because this is what I'm supposed to find out. 3 into ABC, that is their LCM. So I can directly get from here. And the problem will be solved. This is equals to what now? 1620. So what is 3ABC? That is my final answer. That is equals to 1620 divided by 9. And that will be the LCM. Let's just solve this to reach to the final answer. So this is what? Will this go by 9? Let's just solve it completely. So 9 ones are 9. 6, 7, 8, 9. Right, it will go. 9 ones are 9. So what is remaining now? 7, 9, 8 are 72. 0. So the LCM of this 3 number is 180 and the problem is solved. So I just applied the property that I know, but now instead of 2 numbers we take 3 numbers and nothing really changes. You get an additional number here and it comes out to be 3C, and then you apply everything that you have learned with property to reach to your final answer. So we continue with the application of property. Let's see what is this sum saying here. The sum says how many pairs of natural number both less than 100 are there such that their difference is 49 and their HCF, highest common factor, is equals to 7. So again, I am not being asked about the number, I am asked about how many numbers can you make, okay, such that their HCF is 7. So I can write 2 numbers as 7 into A to be my one number and other number will be 7 into P. Okay, how do I do this? I know my property X, XA and XB. The difference is 49. So what do I know from this? 7A minus 7B, if these are my 2 numbers, the difference is equals to what? 49, because these are my 2 numbers. And both these numbers, one is 7A and the other is 7B, are less than 100. Okay, this is what you have to understand, are less than 100. So how many such numbers can you form? Okay, what do I know about A and B? A and B are co-prime to each other, so I'll take a 7 common from here. What will be remaining here is A minus B. So that's what remains here. And this entire thing is equals to what? 49. So I get A minus B is equals to what? I get A minus B is equals to 7. Which means that the difference of A and B is equals to 7. So what are the values of A and B that I can get from here? A could be, say, I can start from 8. And B could be 1. 8 minus 1 is 7. I can start with 9 then. 9 minus 2 is 7. Then I can go on as 10. 10 minus 3 is 7. 1, 2, 3, 4. Okay, what? 11. 11 minus 4 will be 7. I can take this as 5. This will be what? 12. 12 minus 5 will be 7. I can get this as then 6. And this will be 13 minus 6 is 7. I can get this as 7. Can I get this as 7? No. Okay, because if I get this as 7, 14 minus 7 will be again 7. Right? I can get this in this way as well. But then there is a problem. What is the problem? Their highest common factor will not be 1. And my condition here is A and B has to be co-prime to each other. They will not be co-prime. So I cannot get it from this point onwards. Okay, even if you go ahead now, if you take this to be as now, you will say I'll take the next one then. I'll take the next one which is 8. But then again there is a problem here. If you can see, the number has to be less than 100. So if the number has to be less than 100, 13 sevens I will get if I take this last combination. Okay, A has 13. So 13 sevens are, if if I put this as 13, this will come out to be 91. And if I put this as 6, which is B, 7 6 it is 42. This will be my two numbers then, okay, which is 91 and 42 with the combination of this. If I go beyond this, 14, if I take 8 of this and if I take 15 of this will become complicated, because this will become more than 100 now. If you take this to be as 14 into 7 is what? 70 plus 28, that will be equal to 14 into 7, 98. Okay, that should not be a problem. But if you multiply this by 15, this is 105. The number will be greater than 100. So you cannot go beyond 14. You can't even take 14 because they are not co-prime. You can't take 15 onwards because the number will be greater than 100. And here I know both the natural numbers are less than 100. So you have to stop here. So how many pairs did you get? 8 and then 1 co-prime, 1, 9 and then 2 co-prime, and co-prime. 1, 2, 3, 4, 5, 6. 6 should be your answer. 6 pairs of numbers you can form such that their difference is 49, their HCF is 7. Both will be the natural number less than 100. In case you are curious enough to find out what will be the number, 7A and 7B is what will be my number. So take one's A as 8 and B as 1. 7 into 8, 56, and 7 will be one number. Take this as 9 and this as 2. 7 into 9 is 63 and 14. Take this as 10 and this is 3. 7 into 10 is 70 and this is 21. Take this as 11 and take this as 4. 7 into 11 is 77 and 28. Take this as 12. Take this as 5. 12 sevens are 84. 7 5s are 35. And last is already we got it here, 91 and 42 with 13 and 6. Both of them are natural number, correct? Both of them are less than 100, correct? They have their HCF as 7. They have a difference of 49. Got it. Okay, so these many numbers can you form. So how many such pairs are there? 6 pairs of number. Okay, no need to do any of this. You can just reach till here and know that there are 6 numbers which exist. So there are 6 such pairs which will exist. So apply the property that we have learned and you should get the answer to most of these questions. Now before entering into the application of LCM and HCF and looking into how can we apply the concepts that we have learned till now, let us understand a basic concept here which will be required in the application of LCM and HCF. And the concept is known as largest 4-digit number divisible by a number. Okay, so what is the meaning of this? Let's not take 4-digit, let's be simple, which is say largest 2-digit number divisible by a number. So I'll say my number here is 7. And can you tell me the largest 2-digit number that is divisible by 7? You will say 14 7s are 98. Correct? 7 into 14 will be 98. So 98 is the largest 2-digit number that is divisible by 7. That's what you know about here. But in case you don't get this click, so is there any shortcut by which I can get this answer? Or is there any method by which I can get this answer if I don't get this clicks? Yes, there is a method. And the method is I'll write a 7 here and I'll write the largest 2-digit number here, which is 99. Then I'll solve this by simple division. 7 1s are 7. What is left is 2. 29. 7 4s are 28. What is my remainder here is 1. Whatever is my remainder, okay, whatever you get as a remainder, subtract that remainder from 99. Okay, which means what are you saying? 99 minus 1, 98 will obviously be exactly divisible by 7, and that is my largest 2-digit number. That's what I got it here. In short, what are you doing? If you get the remainder as 0, you know that this number is exactly divisible by 7. So you start from the largest 2-digit number. Whatever is the remainder that you get, you will obviously subtract it from this to get to your answer. Okay, and that's quite the logic. If I put a 99 here, if I divide it by 7, I get the remainder as 1. Which means if I subtract 99 minus 1, that is nothing but 98. That will be exactly divisible by 7, and that becomes my largest 2-digit number. Okay, so that's a simple plain logic here. If I ask you the largest 3-digit number, you will do the same. Now what will you do? You will keep the 7 here and you will keep the largest 3-digit number here. whatever the number will be, obviously it is 999 or less than 999. Okay, that's what we'll have to find out. If the remainder is 0, it means the number is 999. If I get some remainder, subtract that remainder from 999 and that will be your answer. So let's solve this. 7 ones are 7. What is left is 2. Then here 9. 7 4s are 28. What is left is 1, and then 9 from here. 7 2s are 14. What is left here is 5. So what do you mean by this? If I subtract 5 from 999, okay, I will get a number that will be exactly divisible by 7. So I subtract 999 minus 5 is 994. That will be exactly divisible by 7, which means this becomes the largest 3-digit number that is exactly divisible by 7. If I ask you the largest 4-digit number, what will you do now? 7, and here you will keep as 9999. Now again you will solve, get the remainder and subtract that remainder from this to reach to your final answer. I hope you are getting the basic logic behind this. Now it can be anything. Instead of 7, I'll ask you 21 as well. I can give you any number. So largest 3-digit number divisible by 21. You will say right here 9999 and then start solving it. 21 what? 3s are 4s are. 21 4s are 84. What are you left with is 15. Okay, 84 plus 5, 89 plus 10. 9. Now what? How will you solve this? 26 7s are 147, right? 147. What are you left with is 12 and 129. Then what? 21 6 are is 126. What is the remainder here? 3, which means if you subtract 3 from 9999, which means you will get 9996. That will be exactly divisible by 21, which means this becomes the largest 4-digit number that is exactly divisible by 21. And that's how simple the concept here is. Okay, let me take one more example here. Let's take the number to be as 17. Now I am asking you, now see to the question, smallest 4-digit number. What did I ask? Smallest 4-digit number that is exactly divisible by 17. So which is the smallest 4-digit number? Start from this, 1000. Okay, you will start from this. Whatever is a number, it will be more than 1000. It will be equal to 1000 if possible, which you can see it's not. It will be more than 1000 because the smallest 4-digit number is 1000. It has to be more than 1000. So now I'll see what is the answer that I'm getting it here. So I'll start solving it. 17 what? 17 1s are not possible, then 17 6 are 60 plus 42, 102 no. 17 5s are 85. What are you left with is then 15. So this is 0. Then what? 17 6 are 7s are or 8s are 80 plus 56. This will be 136, correct? So this becomes 136. Now what are you left with as a remainder here is 14. What is the meaning of this? If you subtract 14 from 1000, which comes out to be what? 986, correct? 986. Add 14 to that, you will get 1000. So that is the number that is exactly divisible by 17. But this is the what you will get this as a number which is the largest 3-digit. I want the smallest 4-digit. So add 17 to this. Add 17 to this. Okay, you will get then the next multiple of 17. So what is this coming out to be? This is 1003, and that is your answer. That's your answer. The smallest 4-digit number that is divisible by 17 is 1003. Now in case you want to solve it in one more way, you can think about this as well. This is 14 remainder. If you add 3 more to this, you will get 17, and that number will exactly be divisible by 17 then, right? Because the remainder is 14. So if I add just 3 to this, if I add 3 to 1000, it becomes what? 1003, and 1003 will be the number that will be exactly divisible by 17, and that becomes the smallest 4-digit number. Okay, so that's one concept that you need to understand before we actually move on to understanding the application of LCM and HCF. Okay, I hope you got the idea about how to get the largest 2-digit, 3-digit, 4-digit and the smallest 4-digit, anything which is being asked. They can ask you largest 5-digit here as well, but now you know what is a method to find out the answer for that. So now let us start with the application of LCM. So the first question that I ask you with the application of LCM is this: smallest number that is exactly divisible by 3, 4 and 5. Which is that number? Think about it. It needs to be the smallest and it is divisible by 3, 4, 5, which means I am talking about LCM now. So what is the LCM of 3, 4 and then 5? 5 into 4, 20 into 3, 60. 60 is my number. 60 is that smallest number which will be divisible by 3, 4 and 5. In short, I asked you the LCM of this 3 number. Next question. Smallest number when divided by 3, 4, 5 leaving a remainder of 1 in each case. Which means what? I need a number that is smallest, and when I divide it by 3 it gives a remainder of 1. When I divide it by 4 it gives a remainder of 1. When I divide it by 5 it gives a remainder of 1 and the smallest. So what will that be? Add 1 to 60. Add 1 to 60, that will be 61. 61 is that smallest number which is when divided by 3, 4, 5 leaves a remainder of 1 in each case, because we know that the LCM of 3, 4, 5 is 60. Just add 1 to that. In case they tell you leaving a remainder of 2 in each case, so just find out the LCM which is 60 and add 2 to that. So if you want the remainder, just get the LCM and add whatever is the remainder that they are asking you to add. Let's see the last part of it. So we know the first two, let's see the last part. Smallest number when divided by 3, 4, 5 leaves a remainder of 1, 2 and 3 respectively. So what is the meaning of this? If I divide that number by 3, it will give me a remainder of 1. If I divide that number by 4, whatever that number is, let that be x, it gives me a remainder of 2. And if I divide that number by 5, it gives me a remainder of 3 respectively. Okay, 3, 1, 4, 2 and 5, 3. If you can see it there is a pattern. And what is the pattern that I am talking about? Divided by 3 leaves a remainder of 1. So the difference between 3 and 1 is 2. Divided by 4 gives a remainder of 2. So the difference between this 4 and 2 is 2. Divided by 5 gives a remainder of 3. So the difference between this 5 and 3 is 2. The difference will always remain to be constant. Here also it is 2, here also it is 2, here also it is 2. And it has to be constant, or else you cannot solve this problem. Okay, now what will I do? I will first find out my LCM. So what I did here, found the LCM. What I did here, found the LCM and added the common remainder. Added the common remainder to this. And it was simple then. What I'll do here is find out the LCM. I found out the LCM, which is what here? 60. So I know that the LCM is 60. Then what do you do from this? Whatever is a number that you get as a common difference, 2 here. Okay, whatever is a number that you get as a common difference, subtract that number from this LCM. Subtract that number from this LCM. Okay, that common number. Because you don't have a common LCM here, so you have a common number. So what did I do? I got the answer as 60. What is the common number here? 2. LCM is 60, right? 60 minus 2. Answer is 58. So 58 is that number. When you divide it by 3, you will get a remainder of 1. When you divide 58 by 4, you get the remainder as 2. When you divide 58 by 5, you get the remainder as 3, and it is the smallest number. That's why it is called as application of LCM, because all that I did in all the 3 cases is find the LCM 60. But in the second case, I added the common remainder to get the answer to this. In third case, I subtracted the common number from the LCM to get to my answer, and that's why it's an application of LCM. Okay, now how can I further complicate this? I'll say I don't need the smallest number. I need the second smallest. I need the second smallest. Okay, so what will be the second smallest? So first find the second smallest number, that will be 120. Correct? After 60 it will be 120. That will be exactly divisible by 3, 4, 5. What will be this number leaving a remainder of 1? Add 1 to 120. 121 will be the second smallest. So just replace all this smallest by second smallest, and you will get this. Again, I need the second smallest number, which when divided by 3, 4, 5 leaves a remainder of 1, 2, 3 respectively. So what will you do here? First you will write the second smallest number 120, and then you will subtract the common difference from this. What is the common difference here? 2. 120 minus 2, the answer is 118 is that number which is second smallest, and that's how you can find this out. How can I further complicate this? I'll ask you largest, say 4-digit number or 3-digit number. I can ask you largest, say, or say smallest 4-digit number. I can ask you anything. So let me go for, say, smallest but 4-digit number. Smallest 4-digit number that is exactly divisible by 3, 4, 5. So what will you do now? We had learned how to find out smallest 4-digit number exactly divisible by 3, 4, 5. What is the meaning of this? Exactly divisible by 60. That's what I'm asking. So can you tell me the smallest 4-digit number that is exactly divisible by 60? The smallest 4-digit number is 1000. I'll write here first the technique that we learned in the previous video. Now just keep on solving this. It has to be more than 1000 or 1000, right? Because 1000 is the smallest 4-digit. So let's solve this. 61 is 60. What are you left with is 40, 0, 66 are 360. Okay, what is my remainder here is 40. Subtract 40 from 1000. That number will be exactly divisible by 60. That will be 960. Okay, but I need a smallest 4-digit, so I cannot have this. I'll have to add 60 more to this. So 1020, or you can say just add 20 to this. That will be quite simpler. Okay, if you add 20 to this, it becomes 60, so add 20 to this. 1020. That's my answer. 1020 is the smallest 4-digit number that is exactly divisible by 3, 4, 5, which is exactly divisible by 60. Now replace this smallest 4-digit number. Okay, I'm asking you smallest 4-digit number that is when divided by 3, 4, 5 leaves a remainder of 1 in each case. So what will you do here now? Add 1 to this. Just find out the LCM and add 1 to this. So my answer will be what now? 1021 is the number when divided by 3, 4 and 5 leaves a remainder of 1 respectively, and it's the smallest 4-digit number. Next, I'll put here smallest, here again 4-digit number. Smallest 4-digit number when divided by 3, 4, 5 leaves a remainder of 1, 2, 3 respectively. So what is the trick here? You write the number. You write the number which is my LCM. My LCM is 1020. And then what do? You subtract from this. What do you subtract? What is a common number that is a difference here? That is 2. So subtract from this 2. So what is my final answer to this? 1018. That is my smallest 4-digit number. When divided by 3 leaves a remainder of 1, 4, 2, and divided by 5 leaves a remainder of 3. Now in this case they can ask you anything, largest 4-digit. So for that case you will put a 60 here, and then you will put a 9999 here, and go ahead and solve this. Once you get this, you know how to get this, you know how to get this as well. Largest 5-digit, you know how to find this. Okay, so this is an application of LCM. Okay, this is how you apply the concepts that you have learned with LCM to find answer to different types of questions. Now let's solve few problems on application of LCM. So what is this problem saying? Find the greatest number of 5-digit that is divisible by 32, 36, 40, 42, 48. So as soon as I see number is divisible by this, so I need a multiple of this number. So it's an application of LCM. Greatest number of 5-digit. I know how to find this out. Okay, so what is this actually? This is what we studied in the previous problem. Smallest number exactly divisible by 3, 4, 5. So we found out the LCM of 3, 4, 5. That was 60. From the LCM, you can find anything that you want. So instead of a 3, 4 and then 5, I give you this big number 32, 36, 40, 42 and 48. So I'm just replacing the smaller number by this big number, but the concept here is same. First you will find out their LCM, the LCM of 32, 36, 40, 42 and 48, then the greatest number of 5-digit. So then you will go for this process, right? You will keep the LCM here and you will keep 99999 here. From this LCM you can find out possibly anything, smallest 4-digit, largest 4-digit, largest 5-digit and anything. So first I need to find out the LCM of this number. So let's go ahead to do that. It is the same sum, it is just that now the numbers are big, so I'll go ahead to find out their LCM. Which method? Let's do it by prime factorization. Okay, it will be a great practice then. So 4 8s are 32, 2 square into 4 8s are 32, or I can write it at 2 raised to 3, which is nothing but 2 raised to 5 is 32. 36, 9 4s are 3 square into 2 square. 8 5s are 2 cube into 5. 7 6 are 7 into 2 into 3. 6 8s are, so 2 cube, or 16 4s are 16 3s are 2 raised to 4. 16 into 3, 16 into 3 is 48. Okay, so that's what I get from this. Now I'll write all the distinct number that I can see here: 2 and then 3 and then 5 and then 7. Okay, this is all that I can see here. Now I need the highest power of what first? I need the highest power of 2. What is the highest power of 2 here? I can see here it is 5. So I'll write it here as 5. What is the highest power of 3? Let's check it here. 3 to the power 2, 3 to the power 2, right? This looks to be the highest power. So 3 to the power 2. What is the highest power of 5? Highest power of 5 is 1 here. Okay, that's the only thing I can see here. So that is 1. And then I need 7. 7, what is the highest power? That is equal to 1. Okay, so I'll write a 1 here. That's what I get from this. So this is 2 raised to 5, 32 into 9 into 5 into 7. So what does this turns out to be? Let's multiply 9 into 2. This will be 18. 9 3 are 27 plus 1 28. 288. And then 5 into 7 will be what? 35. Now let us just multiply this to reach to our final answer. 288 into 35. That will give me my LCM. 8 into 5, 40. 8 5 are 40, 44. 5 into 2, 10. 14 into 8 into 3, 24. 24, 26. And 3 into 2, 6 plus 2, 8. Okay, that's what I get it here. 0 4 4 8 6 7 8 9 10 8 9 10 1 0 0 8 0 1 0 0 8 0. That is my LCM of this number. Okay, now what do I need to find? The greatest number of 5 digit that is exactly divisible by this. So I'll keep 10080 here. And what is the greatest number of 5 digit? 99999. Right? That's what I'll write it here. And then I'll just find it out to reach to my answer, or else you can do it directly as well. You need greatest number of 5 digit, right? So it has to be lesser than what? Your 10,000. Okay, so how will you know? So it has to be greater than your this greatest number of 5 digit is this. It has to be just lesser than that number. Okay, so you can just multiply this by 9. Since this is 10,000, it will come in lakh. Okay, I said 1000, but it will come in lakh. So just multiply this. 9 into 0, 0. 9 into 8 is 72. So 7 comes here. 9 into 0, 0. 90720. Because you know that it has to be in the range of 90,000. If this is in the range of 10,000. If I multiply this by 10, it will be not the greatest number of 5 digit. It will be more than lakh, which I don't want. Okay, or else if you cannot get the click, solve it by the normal method. This into 9. This into 9 is what? 90720. Now if you subtract this from this, what is the remainder that you get? This will be 9. 9 minus 2 is 7. 9 minus 7 is 2. And this will remain to be as a 9. 9 to 7, 9. Now if you do this, 99999 minus of this, which is 9279, what will you get the answer as? This is 0. This is 9 minus 7 2, 9 minus 2 7, 9 minus 9 0. This comes out to be 9, which is nothing but the same answer. Okay, so you can think by logic as well. If I get it in the range of 10,000 and I need the largest 5 digit number, so I have to multiply this by 9. Correct? So I get this number. If I multiply this by 10, it will not be greatest 5 digit. It will go to 6 digit then. It will go to a lakh, which I don't want. So I have to multiply it by 9. Okay, or else you can check it in this way. Just write the largest 5 digit, get the remainder, subtract 2 reach to the final answer. So this is my final answer, 90720. So it was just the same concept which we studied it here in the properties. Instead of 3, 4, 5, I gave you big numbers. You found out the LCM. Here it was 60, now it came to be 10080. Then I asked you the largest 5 digit. So how to find out largest 5 digit? You write the LCM here and then you write the largest 5 digit to reach to your answer. So it's all connected. It is just that you need to get your concepts clear to solve such problem. Let's see the next application of LCM. Now I need to find out the smallest number when divided by 2.5, 20, 12 and then 7.5 leaves a remainder of 2 in each case. Okay, so this is our second type of what we have done earlier. If you can see it here, the second type, which is this smallest number when divided by 3, 4, 5 leaving a remainder of 1 in each case. So what do you do for that? First find out 3, 4, 5 LCM, which is nothing but 60, and then add 1 to that, because then it will leave a remainder of 1, and that's what I'll do it here. Okay, and as soon as you read this divided by, you understand it's an application of LCM. So I need to find out first the LCM of this 4 numbers, 2.5, 20, 12 and then 7.5. I need their LCM first. What will I do here is first I'll multiply each one of them by 10 so that I can make my calculation easier. In case you don't do this, it's still okay, you will get the answer, but this is how I'll prefer. 25, this becomes 200, this becomes 120 and this becomes 75. Now I need a number which is an LCM of all this, number. So which will be that number now? Let's check it here. That will be, let's start from 200. Okay, 200 into 1 is 200. That will not come as a multiple of 75. Into 2 400, into 3 600. Now can I get 600? 600 will be a multiple of this, will be a multiple of this, will be a multiple of this as well. Yes, this will be a multiple of this, into 5, and will be a multiple of this as well, right? 75 into, yes, it will be 600. Okay, which is actually a multiple of all of them. Okay, in case you are wondering how, let's do this. 75 into 8, 7 8s are 560 plus 8 5s are 40, 600. Okay, and this is into what? 5, 120 into 5, this is 200 into 3, and this is 25 into 2 is 50 into 4, right? That is how you will get to the LCM of this. So you got the LCM as 600. Now once you know the LCM as 600, I multiplied this by 10. So divide it by 10 to get to the actual answer, 60. 60 will be the LCM of this 4, because I had multiplied this by 10. So eventually I divide this by 10, I get the answer as 60, which is an LCM of this 4 number, 2.5, 20, 12 and then 7.5, leaving a remainder of 2 in each case, which means whatever is my answer of the remainder, add 2 to that. So the final answer comes out to be 60 plus 2, which is nothing but 62, and that's my answer. Okay, so quite a simple, again, the application of LCM. Just find out the LCM, and whatever is the next operation that is being asked, perform that to reach to your final answer. Now let's come on to the next question on application of LCM. So the question says, what is the greatest number of 4 digit that when divided by this number of 6, 9, 12 and 17 leaves 5, 8, 11 and 16 as remainders respectively? Okay, so what is this type? If you can comment here, this is the last type that we have done. Smallest number when divided by 3, 4, 5 leaves a remainder of 1, 2 and 3 respectively. What do you see here? You see here the difference. 3 minus 1, 2, 4 minus 2, 2, 5 minus 3, 2. Eventually you find out the LCM of this 3 number and you subtract the difference. Okay, in case 3 digit or 4 digit number asked, you find out that number and subtract the difference. That's what I'll do it here as well. So instead of 3, 4, 5, I have this number which are 6, 9, 12 and then 17. First I'll find out their LCM, okay, and then I'll find the greatest 4 digit number that is divisible by their LCM. From that number, I'll subtract this difference. This difference has to be constant. 6 minus 5, 1. 9 minus 8, 1. 12 minus 11, 1. And so is 17 minus 16, 1. Okay, that's how the problem is being made. So first find out their LCM. Then find the greatest 4-digit number that is divisible by their LCM, and then subtract 1. So let's start. What is the LCM of these numbers? What will that be now? Let's just do it by traditional method. Looks easy. This is 2 3s are 6, 2 6 are 12, 9 remains here, and this is 17. 3 looks good here. 3 1s are 3, 3 3s are 9, and I have then 3 2s are 6. Okay, so let's write this here. You can calculate it by yourself to see as to what is happening in this. So let's put it here. This is 3 3s are 9, 3 2s are 6, and this turns out to be 17. Now what? I have 3 1s are 3, this 2 remains here, and I have a 17 which will be remaining here. Okay, now that's it, quite simple. 2 1s are 2, 1 1 remains here, and then a 17 which remains here. So 17 1s are 17, and that's where I get 1 1 1, and I get my final thing here. So what is my LCM then? Just multiply all of them. 2 into 3 6, 6 into 3 18, 18 into 2 36, and here I have a 17. So 36 into 17 is my final answer. Let's multiply. 7 6 are 42, 7 3 are 21 plus 4 25. Then cross here. 1 into 6 is 6, 1 into 3 is 3. This is 2, 5 5 10, this is 11, 3 4 5 6, 6 1 2. So 6 1 2 is the LCM of this 3 number. I need the greatest 4-digit number, so put here as 9 9 9 9. Get the remainder and subtract the remainder to reach to your answer. So let's solve this. 6 1 2 1s are 6 1 2, correct? What is it like? I'll get it here. 9 minus 2 7, 9 minus 1 8, 9 minus 6 3, 387, not going, so let's put a 9 here. Then what? 3 8 7 9 is what I get. 6 are, yes, 6 are possibly, or 6 6 are 3 6 0 0, or I can say 7. Let's do it. 6 1 2 into 7 is what? 7 into 2 is 14, 7 into 7, this is 8, 7 6 are 42. It's too big. Let's multiply. 6 1 2 into 6, 6 into 2 12. This is 7, 6 into 6 is 3 6 7 2. Okay, is there a mistake that we did here? 7 to the 14, 7 to the 7 8, 7 to the 42, correct? All looks good, right? So I'll have to do it by 6 only. This is equals to 3 6 7 2. Okay, that's how it looks. Now subtract this. 9 minus 2 7, 7 minus 7 0, 8 minus 6 is 2, and this is 0. So I get the remainder here as 207. Subtract 207 from this, and that number will be exactly divisible by 612. So 999 minus 207, what will that be? 9999 minus 207. 9 minus 7 2, this is 9, 9 minus 2 is 7, 9792. That is what I get it here. And that is the largest 4-digit number that is exactly divisible by 612, which means if I divide by 6, 9, 12 and then 17, it will leave a remainder of 0 here. But I want it to leave a remainder of 5 when divided by this. When divided by 9, leave a remainder of 8. Okay, and so on. Divided by 12, 11, and divided by 17, 16. So I'll see the difference, which is 1. Whatever is the difference, subtract this. So 9792 minus their difference, which is 1. Okay, so my final answer here is 9791 is that number. When you divide this by 6, it will leave a remainder of 5. When you divide this by 9, it will leave a remainder of 8. Okay, when you divide this by 12, a remainder of 11. When you divide this by 17, leave a remainder of 16, and so on. So you get the respective remainders with the respective denominators. So if you know the basics, how we started with this thing, the property thing, if you know this, solving each of this type of sum will be quite easy to you. Let's solve few more sums on the application of LCM. So now I'm being said that smallest number, tell me the smallest number, which is when divided by 12, 16 and 18, it leaves a remainder of 1. Okay, but when it is divided by 17, the remainder is 0. So I get a new condition. Okay, when it is divided by 17, the remainder is 0. So first I'll find out what is the smallest number, which is when divided by 12, 16 and 18 leaves a remainder of 1, and that is quite simple. I need to find out the LCM of this 3 and add 1 to that. Okay, I'll get the number. So let's get that first. This will be what now? This will be 4 3s are 12, 4 4s are 16, 18 remains here. Let's do it by 2 2s are 4, 2 9s are 18, 3 remains here. Then this is 3 1s are 3, 3 3s are 9, 2 remains here. Then this is 2 1s are 2 and 3 remains here, 1 is here, and 3 1s are 3 and 1 1 1. That is being solved, 1 here. Now just multiply them. 4 into 2 8, 8 into 3 24, 24 into 2 48, 48 into 3, 48 into 3 is 144, 48 into 3 is 144. So that's my answer. But 144 is a number which is exactly divisible by 12, 16 and 18. I need a number which will give me a remainder of 1. So that will be 144 plus 1. That will be 145. And that should be my answer. But there is a condition here. This is ideally my answer. If this number is divided by 17, it gives me a remainder of 0, which is not happening here. If I divide 145 by 17, the remainder is not a 0. Okay, so that's where I have a problem. So little bit of analysis is needed here. What will I do here? I know the number is of the form 144x plus 1. Because if the first number is 144, that is exactly divisible by 12, 16 and 18. What will be the next number? 144 into 2, 288. That will be the next number. Now if you need a remainder of 1, it means you will add 1 to 288. Okay, earlier you added 1 to 144, you got the number as 145. This is the smallest number, giving a remainder of 1, but does not give a remainder of 0 when divided by 17. Let's check this number. 288 plus 1, 289. Okay, this will give me a remainder of 0. So you will have to put here x as 2. If you put x as 2, this becomes 289. So the second number is what you will need. After 145, the next number will be 289. Okay, that will again give the remainder of 1 when divided by this, but this is not the smallest. But when this is divided by 17, it will give the remainder of 0, because 17 square is 289. Okay, so ideally I would have got my answer as 145, but then I see condition number 2, and then I see that okay, all the numbers which will be formed giving a remainder of 1 will be of this form. So what is the value of x that I can substitute? Earlier I substituted x as 1, I got 145, but 2 was not satisfied, so I got x as 2 now. When I get x as 2, I get second number, so from that I understand remainder will be 0, and that's how simple it is if you know the concepts. So after application of LCM, let us see few problems on application of HCF, highest common factor. So the question is saying me the greatest number that divides. Now that's what tells me this is application of HCF, because now I am not finding the number which will be divisible by this. Now I am finding a number which divides this number. Okay, so I am looking for a factorial. That's what is a differentiation that should click to you. So the greatest number that divides 20, 50 and 40, leaving 2, 5, 4 as remainder. So what do I understand from this? So there is some number, let it be x, that divides 20 and gives me the remainder of 2, and that divides 50 as well and gives me the remainder of 5, and that divides 40 to give me the remainder of 4. What do I understand from this? What is actually this number then? So I understand that when I divide 20 by this number, I get the remainder as 2. So if I do 20 minus 2, I get 18. 18 has to be completely divisible by this number. Similarly, if I divide 50 by that number, I get the remainder as 5, which means 50 minus 5, that is equal to 45, has to be completely divisible by this number. And so is this logic. I'll apply it here. If I divide 40 by that number, I get the remainder as 4, which means 40 minus 4, that is equal to 36, will be exactly divisible by this number. So I need what number now? The greatest number that will divide this number, 18, 45 and 36. What is the greatest number that will divide this 3 number, which is nothing but HCF of this 3 number. So what is the HCF of this 3 number? 18, 45 and then 36. That's what I need to find it out here. What is the highest common factor? And as I can see it here, I can find it out visually. It's 9. 9 2s are 18, 9 5s are 45 and 9 4s are 36. So the highest common factor of this number is 9. And that's my answer. Okay, if you want to believe on this, put a 9 here and you will get the answer. 20 divided by 9, remainder 2. 50 divided by 9, remainder 5. And 40 divided by 9, remainder 4. Okay, so I do get this. So 9 is my answer. So this was quite logical application of HCF. And what will tell me this is application of HCF? A number that divides this number. Okay, so remember this hint of the question. Now let us see one more problem on the application of HCF. The greatest number that divides. Okay, so again we are talking about application of HCF. This numbers 369, 449, 689, 5009 and 729, so as to leave a remainder of 9 in each case. So in the earlier problem I gave you different remainders. Now I am giving you one same remainder. So there is one number which divides 369, giving you the remainder of 9. The same number divides 449, giving you again the remainder of 9. It divides 689, giving you the remainder of 9. And it divides 5009 to giving you the remainder of 9. Which means I'll apply the previous logic. 369 minus 9, which is nothing but 360, will be completely divisible by this number. And so will be 440 completely divisible by this number. So will be 680 completely divisible by this number. And so will be 5000 completely divisible by this number. Let's take the last number here. 729 divided by this number gives the remainder of 9. And so will be 720 completely divisible by this number. So now I need one number which is HCF of all this, because I need the greatest number. So I need one number which is HCF of all this. 360, 440, 680, 5000 and 720. I just need to find this out. What will I do here? Take out 1 0 from all of them, because that's what will make my job easier. Right now I need the HCF of 36, 44, 68, 572. Okay, how will I go ahead to solve this? Can this be 18? No. Can I solve this directly? 36? No. 22? No. Let's just try and factorize this. So I'll keep this as what now? 36 is this, so I'll put this as 9 4s. This is 2 square into 3 square. This will be 11 into 2 square. This will be 68. So how can I write this now? 68 could be written as 2 into 34 into 2, but this is again 17 into 2, so 17 into 4 I can write this as, or 17 into this becomes what? 2 square. This could be written as now 500, so this is 5 into 100, 25 into 4 will be 100 into 5. So this becomes 5 square into 2 square into 5. And this is 8 into 9. So 2 cube into 3 square. That's what I get it from here. What are the distinct number that I can see it here? 2 and then 3 and then 11 and then 17 and then 5. No need to write so much, but just for your understanding I'm doing. What is the lowest power of 2? What is the lowest power of 2? As you can see it here. What is the lowest power of 2? Let's just see. Lowest power of 2 here. It is 2. Here it is 2. Here also it is 2. Here also it is 2. And here it is 3. So I can see the lowest power of 2 is 2. That is the lowest power because it is everywhere. So the lowest power of 2 is 2. What is the lowest power of 3? I don't see any 3 here. Okay, so I can assume the lowest power of 3 to be 0. Lowest power of 11, 0. Okay, because I cannot see 11 anywhere. 17, 0. Because it is there. And 5 is again be equal to 0 because it is not. The answer comes out to be 4. Okay, so 4 is that number. But that will not be my answer because I cut a 0 here. So it will be 40. That will be my final answer. So 40 is one number that will divide all these numbers and give me my final answer. That's it. 40, just divide 369 by 40, you will get the remainder as 9 and so on. Okay, so that's my answer. You could have got this 40 visually as well, but I just wanted to show you the method. That's why we went with this. Let's solve this problem on application of HCF. Now I'm being asked the greatest number that divides 1305, 4665 and 6905, leaving in each case same remainder. So I want to find out the greatest number, but I don't even know the remainder in this case. Earlier I knew the remainder. So I just subtracted and found out the HCF to reach to the answer. And that's where this problem looks to be complicated. So what do I understand? Let's write everything. The numbers are 1305, then 4665 and 6905. What is my number is something that I'm supposed to find out. Let x be the number. So x divides this number, all the three numbers, leaving in each case the same remainder. So I get a same remainder here. Okay, so this you can term to be as a problem when you get the same remainder. So how do I go ahead with this? Now there is a logic by which you should crack this problem. Let me take an example. 5, 10 and 15. I take this 3 number. I'm telling you, tell me the greatest number that divides 5, 10 and 15, leaving in each case the same remainder. So instead of this 3 big number, I replace it by 5, 10 and 15. So what is that number? We know it is 5. Leaving in each case the same remainder will be 0. I know I can get it visually because the numbers are easier. Is there any other logic? Yes, there is one more way to solve this as well in case I don't get the answer visually, which is happening in this problem. Take the difference. 10 minus 5, 5. 15 minus 10, 5. 15 minus 5, 10. Okay, in the end you have to do this. Now whatever are the number that you get, take the HCF of that, highest common factor of this number. So what is the HCF of 5, 5 and 10? Highest common factor, it will be 5, and that is what our answer was. That is what I told you earlier, that the remainder will be 0. Take this any number, this will always happen, say 60, 90, then say I am taking here as 100. Now take the difference between these two, same question, highest number which divides, greatest number which divide them to give the same remainder. So take 60 minus 90, it is 30, 90 minus 100, it is 10, 100 minus 60, it is 40. So what is the HCF of this 3? It is equal to 10, and we know that 10 is the number which divides them to give you the same remainder in each case, which will be equal to 0. 10 9s are 90, 10 6 are 60, 100, 10 10s are 100. Okay, but I got the highest number here, which is 10. So how do you solve this now? Take our three numbers, 1305, 4665 and 6905. What do I do here? Subtract this with this first. 4665 minus 1305. Let's do this. What is the answer for this now? This comes out to be 0. This is coming out to be as 6, and this is 3, and this is 3. This is coming out to be as 3660. Okay, is it correct? This is 0. This is 6. This is 3, and this is 3. Correct. Now let's go here and find this out. This comes out to be a 0. Then this comes out to be as 10 minus 6, this is 4, this is 8 minus 6, 2, and this 6 minus 4, 2240 is what I get. And let's subtract them now. 136950 minus 1350, this is 0, this also is 0, this is 9 minus 3, this comes out to be as 6, 6 minus 1, it will come out to be as 5. Okay, so 5, 6, 6. These are the three numbers that I get. Now, my only job is to find out their HCF, highest common factor of this three number, and that will be my answer. That will be my answer. That's what we did it here as well. So let's first find it out. Let's keep the number as this number, 1 to be as 560, 1 to be as 336, and 1 to be as 224. I need to find out their highest common factor. So can I solve this visually? Yes, I can. 112. Think about it. 112 into 2 is 224. Into 3 is 336. Into 5 is 560. So I know 112 will be the highest common factor here. Okay, because I am keeping here the prime numbers aside, and 112 I am getting it here. So I know their highest common factor will be 112, but I did not take a 0 here. If I add a 0 to all this becomes 1120. So 1120 is my answer. That's the answer. That's the greatest number that divides this number, leaving the same remainder in each case. Okay, you don't believe to this, then divide it. Let's divide 1305 divided by 1120. Okay, what's the remainder that I get here is, that will be I think 185, right? Yeah, 1 is this, and I'll be getting the remainder here as 10 minus 2, 8, 185, right? That will be my remainder. Okay, similarly divide this by this, you will be getting this 1120. Again you will get the remainder as 185, which is the same remainder, giving the same remainder in each case. And if you divide this also by 1120, it will give you the same remainder of 185. Okay, so that's how simple it is to solve this problem. Remember the basic technique here, which is take the 3 number, take their difference, get 3 more number, get their highest common factor, and that will be the greatest number that divides these 3 numbers to give you the same remainder in each case. Now let us see a few word-based and story-based problem on application of HCF. So till now we just solved numbers with respect to application of LCF. Now let's put it in real life and see how do we apply what we have learned with HCF. So what does this problem say? The problem says that there are 289 girls and 340 boys in different sections of Gurukul, such that each section has equal number of students, and in each section you have either boys or girls, which means you cannot form a section in which you have both. One section has only boys, then the other section has only girls. Okay, so either boys or girls. You cannot have a section which is mix, having boys and girls. That is not possible. You either have boys or girls. Then the question is asking me, what will be the minimum number of sections in Gurukul? So what will be the minimum number of sections is my question. So let's start analyzing them. How many girls are there in Gurukul? There are 289 girls. Okay, and how many boys are there? There are 340 boys in Gurukul. Now if I think maximum number of sections, so I'll say just keep one girl in one section. So how many sections will I form like that? If I keep one girl in one section, 289, right? 289 sections I can form it here. And if I just keep one boy in one section, so how many sections will I form like that? One boy in one section, I'll have 340 sections for boys, and I'll have 289 sections for girls. But what will this give me? 289 plus 340 will be the total number of sections in Gurukul, right? But that will be maximum. That will be maximum number of sections that I can form. How can I make this minimum? I will have to put in more student in one section. Per section I will have to put in more student. But the number of student in each section are equal, which means the number of girls that I'll put in this section and the number of boys I'll put in this section has to be equal. So if I take any random number, say 10, if I put 10, 10, 10 like this, it will not be possible to do that because it is 289. Okay, eventually I'll end up one section, student are 9. I can put it 10 here, of course, I can put it 10 here and I can complete this 340, but I cannot do it here. So I need a number which I can put in both the section, and that is maximum possible. And how do you know 10 is maximum? What if I say put it like 100? Okay, then it will not be possible in each of the case, right? So that's what you have to think, which is the maximum number that I can put in this such that all the conditions are being satisfied, and that is when the concept of HCF comes into the picture. So what is HCF of 289 and 340? Visually I can say it is 17. Okay, because I can see what will be the answer, because 17 into 17 is 289, that is what I know, and 17 into 2 is 34, so 17 into 20 will be 340, which means what? Put 17 student in each section, so that there are 17 girls. With 17 girls in each section, how many section can I form? 17 such sections, such that I can accommodate in this 17 section 289 girls. So I have 17 section here. And with 17 boys form 20 sections, from 20 sections, such that I can accommodate how many boys here? 340 boys. So how many sections did I make? 17 for girls and 20 for boys. 24 boys. So total number of sections here are 37 sections I completed, and that's what gives me the solution to this. So that's how you apply the concept of HCF that we have learned till date, because till the time you know what is HCF and what is the power that it handles, you won't be able to get the solution to this. Okay, so understand, analyze and apply it in the right way. Now let's see application of HCF and story based problem. So we continue with that. So what is this story saying? This story is of Darzi. Darzi wants to cut a rectangular piece of cloth of length is given to me as 14 meter and breadth of 20 meters. So as you can see it here, there is a rectangular piece of cloth of length and then breadth 14 and then 20 respectively. What else? Piece of the cloth has to be cut in small equal squares. Okay, so I need to cut out of this small equal square such that no piece of the cloth gets wasted. So I need to use the entire cloth and make equal squares out of this cloth. Find the maximum number of squares, and that is quite simple. Maximum number of squares will be infinite, because I can make my square as small as possible. I'll cut this much, next is this much, next is this much, 0.001 meter, and then I'll keep on going with this. So maximum can be what? Infinite. Maximum squares that I can cut from this, that is quite clear. Next question looks challenging, that is minimum number of squares. The minimum number of squares that can be made from this piece of cloth. Okay, so minimum number of squares. So what will I find out is if it is a square, it needs to have equal sides, right? When is this possible? How can I make this 14 and 20 have equal side? By taking the HCF of 14 and 20. Okay, if I can do that, then only I can make this to be minimum. You can tell me that you can take this as 1 and 1 as well, 1 centimeter and 1 centimeter, not a problem, but that will not be minimum possible. I want it to be minimum as possible, and that's why I need to take the HCF of this, the maximum that I can take from 20, the maximum that I can take from 14, and that is nothing but 2. 2 is the highest common factor of 14 and 20. So I'll make one square out of this which is having the side of 2 centimeter, which means I'll take out 2 from here and I'll take out 2 from here as well, and that's how I'll keep on taking the squares out of this cloth. Okay, so what do you think? How many can I take from this? 1, 2, 3, 4, 5, 6 and then 7 I can take from this, right? Because this is 14, so 2 like this. Okay, similarly, how much can I take from this? I can take from here 10. Okay, just going like this, I can take out 10 from here, because this is what, 20. And that's how I'll keep on taking like this square. I'll take the 2 from here and keep on taking like this. Now what is he asking me now? How many squares can you take? So if I keep on doing this, I cannot calculate this by drawing, right? How many squares can you take from this? That's what he's asking. So first I'll say, what is the total area of this cloth? That is nothing but 14 into 20. Length into breadth is the total area of this. What is the area of one square that you are taking it out from this one square cloth? What is the area of this one square cloth? Okay, that is nothing but 2 into 2. Area of the square, side square. That is nothing but 2 into 2. So this will tell me how many squares can I take out from this. So if you say the total area is 100 and the length and the area of each of the square is 2, then you can take out 50 such square from this, right? That's what the logic. That's what I did it here. The total area of the cloth is this. The area of one square is this. So I can take out these many cloth, and that will give my answer. So let's cut this. 2 ones are, 2 tens are, 2 ones are, 2 sevens are. 7 into 10, answer is 70. So 70 is the minimum number of squares that can be made from this piece of cloth. Okay, and maximum we know is infinite. We can take out many, but I want minimum. That's why I need the concept of LCM.